Hello, welcome back. So let's continue our discussion using Desmos in terms of using our in terms of solving particle motion questions. So the next question we have is we want to find acceleration at time t. Now we have to find the acceleration. So if you remember up here, our velocity equation was this kind of a quagmire right there. So let me copy that down here and I will paste it. Okay. So there is my velocity equation. So we know to get acceleration, we have to take the derivative of that question. Now, we're only going to take the derivative of it. We're not ever going to use it. I'll show you why, okay? And this is going to be, again, quotient rule. So it's going to be the low, t squared plus 1 squared, low. D high becomes negative 2t minus high, negative t squared plus 1 d low, and this is where it gets awful. Let me go ahead and erase all of this because this is where it gets pretty bad. D low, that's my chain rule. I'm going to get 2 times t squared plus 1 to the first times 2t, all over that bottom squared. Now, what did I just say? We're going to take the derivative because we're being asked to. We are not actually going to physically use this derivative because if you notice, the next part says we want to find the acceleration at 3. This is where calculators and Desmos are really nice. To get the acceleration at 3, remember, we're really looking for the derivative of velocity at 3. And I can use Desmos to do this. So let's go back over to my Desmos graph. You might remember we used this f of t right here for our derivative for the velocity. Remember, this is my velocity equation. So all I have to do is find the velocity, the derivative at 2 for that graph. So I can do that really easy if I just go down below here. I'm going to find f prime of 2. That's it. Whoop, we wanted 3. Excuse me, terribly. Or 0.036. So that's what we get. We get this 0.036. Now, with this is acceleration, so this is going to be meters squared per second. And there is our velocity or acceleration at 3. What if I want to find the acceleration at 0? I just go over here, type in 0. There it is, 0. I can, what if I want to find the acceleration at 10? There it is. There's the acceleration at 10. It's just a derivative. What if I want to be a jerk about it? Find the second derivative at 0 at 3. Oh, there it is. There's the jerk at 3. So the Desmos allows us to use the derivative without actually really physically having to take the derivative. And that's a really nice tool because if you look over here, this is not a fun derivative to mess around with. So sometimes when you're given the opportunity to use Desmos or a calculator, use it because it's just really there to help you get the answer. You still have to show understanding what everything means by understanding we're looking for a derivative at that point, and that's really what we're grading here. All right, the next question. This is a fun one. When is the particle speeding up or slowing down? So you might remember this one is we're going to need a double sign chart. I love the double sign chart. So we need to find where velocity is 0, which we already know is 1, and we need to find out where the acceleration is 0. So to find out where the acceleration is 0, remember, this is the slope of velocity. This is our max and mins of the velocity equation. So if I come back over here to my Desmos, over here, and I just touch anywhere on the velocity graph. Remember, not the green one. The green one, that is our position graph. I look at the velocity graph. I just touch anywhere on there. I just touch anywhere in either graph. It's going to give me these points right there. You see these points? Coming over here, I get these following points right here. There we go. I get those points. Well, what's so important about those points? Well, notice at the very top, up here at the very top, right there, where it's 0, 1, notice the slope is 0. Well, that's the slope of my velocity curve, which is telling me that at that point, my acceleration is 0. So I can include 0 right there. Another one, take, let's look right down here. Well, that is a point right there, but that again that's where it crosses 0. That is just saying where my velocity is 0 right there. So that's not really going to help me much. But this point down here, if I zoom in enough, at that point, notice down there, my slope is 0, and that's my other point. That's this 1.732. And now I can draw my double sine chart over here. Starting at 0, on top I'll put velocity. Whoops, I only have the 1. And I already have my sine chart from velocity. It was positive, negative. On the bottom, I'm going to put acceleration. I just have that 1.732. Now remember, this is the slope of velocity. So if you go before this point over here, if we're before this point over here, notice the slope is negative. So it's a negative slope. And afterwards, it's kind of going up really slowly. So it's a positive slope. So if I want to find out where we speed up on, we're looking for where the signs are the same, and that occurs between 1 and 1.37. 1.732, sorry about that. So on 1 to 1.732, and that's because velocity and acceleration, we said, have the same signs, or they go in the same direction. Where do we slow down? We slow down when they're the opposite signs. So that's on 0 to 1 or 1.732. We're not really restricting our domains here, so forever. So we're always slowing down. We are constantly going to slow down from now on. And this is because velocity and acceleration have opposite signs. You can say different signs, different directions, opposite directions. That's all fine too. And there we go. And that's how we use Desmos to solve a lot of these questions right here. So I'm going to go in another video, and you can take a look at the next two examples. I'll see you then.